Which JavaScript framework is the best? If we go off of downloads, React wins, but based on GitHub stars, Vue is the best. But Svelte is the most loved framework according to the 2021 Stack Overflow survey, and some people out there might even tell you that you don't need a JavaScript framework. And whether you're a new developer or have 20 years of experience, it can be very difficult to choose which framework you want to marry, which is the single most important decision you'll make related to your front-end code. There's no absolute best framework, and the only way to find out which one will make you happy is to build something with all of them. In today's video, we'll build the same app with 10 different JavaScript frameworks, including Angular, React, Vue, Svelte, Lit, Alpine, Solid, Stencil, Mithril, and Vanilla. In the process, you'll learn the trade-offs between each of these frameworks so you can make the best choice for your next project. This video was a ton of work, so make sure to subscribe and hit the like button. Then leave a comment below with your favorite framework, and I'll choose a few random ones to win a free t-shirt next week. The first thing we'll do is build a basic to-do app with vanilla JavaScript. About once a year, a hot take will go viral saying that you don't need a JavaScript framework at all. Any expert web developer needs to have a solid understanding of vanilla.js. But even if you're a JavaScript god, attempting to build a non-trivial app with it is a recipe for disaster. What you'll end up doing is building your own shitty JavaScript framework, and the last thing the world needs is another JavaScript framework. To build an app from scratch, all we have to do is create an HTML file, then add a script tag to the body. What we want to build here is a to-do app where the user can write some text into a form input, then submit the form and have that item appear in the list. In addition, we'll save those items to local storage as kind of a mock database so that when the user refreshes the page, those items are still present. Pretty simple concept, but there's actually a lot going on there, like state management, data binding, events, and the application lifecycle to think about. The one thing that all frameworks do and vanilla.js doesn't is provide a way to bind or connect your HTML to the JavaScript automatically. In vanilla, we need to imperatively grab the HTML elements that we're working with from the DOM. And I can tell you right now, this is a very annoying way to build a complex application. As you can see here in the DOM, we have an unordered list for the to-dos, and then below that, we have a form with an input and a button to submit the form. Now going into the JavaScript, the first thing I'll do is write some code using document query selector to grab each one of these items from the DOM. Now that we have access to the HTML elements, I'm setting up an empty array here to represent the actual to-do items in the list. In addition to keeping track of the data, we also need to update the actual UI when that data changes. For that, I'm defining a function called addToDo that takes a new to-do item as its argument. Now, this is where things start to get ugly with vanilla. In order to update the UI, we need to manually create a new list item element by calling document create element. Then we need to imperatively update its inner HTML to the to-do text. And finally, append it to the unordered list in the DOM. And as an added touch, I'll save the data to local storage so we can access it when the page is refreshed. The problem with this code is that the application data or state is completely decoupled from the UI itself. And that makes it very hard to keep the data in sync with the UI. Now that we have this function in place, we need a way to call it when the user submits the form. For that, we need to register an event listener on the form's onSubmit event. When that event is fired, we'll first call prevent default to prevent it from refreshing the page, then call the addToDo function with the current value in the text input. At this point, we should have a working to-do list. But one important thing to notice here is that if you look at the HTML markup, you really have no idea what it's doing. There's no way to tell this form has an event listener attached to it unless you go search through the JavaScript code itself, which is extremely difficult in a complex application. Now, one final thing to think about is the application lifecycle. When the app is first initialized, what we want to do here is grab the existing to-do items from the local storage and render them in the to-do list if they exist. If there are existing to-dos in local storage, we can loop over them with for each and call the addToDo function for each one of them. Congratulations, you just built a to-do app with vanilla.js. But this code is not going to scale complexity very well. And there's likely many other features we'd want to add, like routing or animation, that we'd have to implement from scratch. And that's why the vast majority of developers choose to build their apps with a framework. First, we have React, which most people would consider the most popular framework. Some people call it a library, but it doesn't really matter because it's a tool that becomes the main driver of your project, requiring you, the developer, to do everything the React way. I don't mean that in a bad way, because React was created by very smart people at Facebook to build complex UIs like the Facebook UI. React is minimal by design and relies on the open source community to handle other concerns like routing, animation, state management, management, and so on. It's not opinionated about how you organize your code, which requires you to make a lot of decisions about which libraries to bring in and how to make things maintainable and scalable. React is by far the most popular framework, with over 10 million weekly downloads on NPM and over 170,000 GitHub stars. Its popularity alone makes it a great skill to learn, because there are many employers out there looking to hire React developers, and you'll find tons of other React developers in the industry to collaborate with. React has an official CLI called Create React App. We can create a new React project by running the create React app command from the terminal. Now, it's worth noting that many people opt for other tools when building a React project like Next.js or Gatsby that would replace the default CLI. When you generate a new project with create React app, you'll notice it has a package JSON in the root of the project, inside of which there's a start script to serve the app locally. Under the hood, it uses a tool called Webpack to bundle all your code together into a single JavaScript file. In React and most other frameworks, your application is organized as a tree of components. These components encapsulate parts of the UI and have ways to communicate with each other. This allows you to organize your app in a declarative way, where for a given set of application data, the end result of the UI will always be the same. Now, in the app.js file, you'll first notice a function called app. That function represents a component in the UI, and personally, I love the simplicity of that. Now, the return value of the function is JSX, which itself looks like HTML, but has been extended with an additional syntax allowing you to insert JavaScript into your HTML. For the to-do list, we can define reactive state on the component with the useState hook. The hook is just a function that will return us with two values. The first item is the value of the to-do list as reactive state, which means anytime it's updated, the UI will re-render to show the latest state. And then the second item is a function to update the state. Now, if we go back down to the JSX, we can loop over the to-do items in the array and render them out directly in the UI as a list item. Then below that, we have an HTML form. But the cool thing about React is that we can bind an event directly to this form using onSubmit. Then on the right side of it, we can reference a function that will be called whenever the submit event fires. And that function will update the state and store the result in local storage. You'll also notice that I'm using the useRef hook to grab the current value of the form input. One thing to notice here is that the HTML is a lot more descriptive. We know exactly which elements our data and events are bound to. Now, the final thing we need to do here is run a lifecycle hook. In React, that can be handled with the useEffect hook, which will grab the items from local storage when the component is first initialized. This hook can be really confusing though if you're just getting started. To only run it when the component is first initialized, I need to add an array as the second argument, and in my opinion, this code is just really hard to look at unless you really know what's going on with the useEffect hook. In any case, React is the gold standard for declarative UI frameworks, but there's more than one way to get the job done. Next, we have React's arch nemesis, Angular, which is developed and maintained by Google, and unlike React, is very opinionated about how to organize and structure a project. It has 75,000 GitHub stars and is the second most downloaded framework on NPM. It comes with officially supported libraries for routing, animation, and server-side rendering, and because it follows a set of predictable conventions, all Angular projects are structured relatively the same and have awesome tooling to go along with them. In fact, you are actually required to use TypeScript. Google uses it internally to build hundreds of different web apps throughout their product line. It's a great option for big teams, but may be a little overwhelming if you're a beginner. To start an Angular project, run ng-new from the command line. That'll give us a fairly large project to get started that's already configured with TypeScript. We can build a component in the appcomponent.ts file, or we could use the CLI to generate a brand new component automatically. In fact, Angular has the most powerful CLI of all the frameworks by a pretty wide margin. And you'll notice the component itself is represented as a TypeScript class that has a component decorator on top of it. Now, it is possible to define an entire component in this TS file. However, most Angular apps break components down into at least 3 separate files, one for your TypeScript, one for the HTML, and another for the CSS. To add reactive state to the component, simply define a property on the class. From there, we can define a method on the class to update the state. In addition, we can manage the lifecycle of the component in the class by implementing special methods like ng-on-init. This method will be called whenever the component is first initialized. Now, if we go into the template, you'll notice this looks like HTML, but it's been extended or empowered with a special templating language that makes it possible to loop over an array of items using the ng-for directive. Unlike React, which brings HTML into your JavaScript, Angular does the opposite and brings JavaScript into your HTML. Then in the form itself, we can bind to the submit event and run the add to do method whenever that event is fired. Then to get the actual value from the form input, we can use two-way data binding using the ngModel directive. This binds the form value to the to-do text property on the class. However, to use this, we need to go into the app module and import the Angular Forms module there because it's required for that directive to work. And for that reason, among many others, it tends to have a much higher learning curve than other frameworks. But everything is here for a reason, and Angular is very opinionated about how to structure a project that will scale well. And that tends to make it very popular with enterprise applications. And that brings me to Vue.js, which is independently developed and maintained by Evan You, and feels very similar to Angular, but in a package that's more approachable for independent developers. It has official packages for things like routing and state management, and a huge ecosystem of third-party packages. It has the most GitHub stars at 187,000, and is basically tied with Angular for second place on NPM downloads. Vue also has a very powerful CLI. For example, we can hit the Vue UI command, which will bring up an actual browser window and walk us through all of the different dependencies and features that we can add when generating the initial app. This creates a really nice developer experience, but it doesn't generate components and is just not quite as powerful as the Angular CLI. You'll notice it generates a far more simplified project structure, but in the main.js file, we can add additional plugins for other functionality like routing or state management as it becomes needed. Components are defined in files that end in .vue. The code is organized into three parts: a template, a script, and the styles. The component itself is represented as a plain JavaScript object, and we can define reactive data or state on it using the data property. Now to change the state, we have the methods property where we can define our add to do method that can be called when certain events are triggered. Then to tap into the component lifecycle, we have methods like mounted that will be called when the component is first initialized. Very similar concepts to React and Angular, the main difference being that we're working within the context of a plain JavaScript object instead of a function or class. In the template, we have a setup that's very similar to Angular that uses directives to handle things like v_for to loop over the to-do items, or v_on_submit to handle the form submission. One thing that's nice here is that you can automatically prevent the default behavior by just adding .prevent to this directive instead of implementing that code in the method itself. You'll find a lot of little things like that in Vue that make your life easier. And lastly, we have the vModel directive to bind the to-do text to the form input value. Vue is awesome and has a big community, but another independent option is Svelte. It was the most loved framework on the 2021 Stack Overflow survey and has about 50,000 GitHub stars. It's not as common as the other three in the wild, but is very well loved by the people who do use it. Like React, it's designed as a minimal library and relies on the open source community for other features like routing. One thing that makes it unique from the other frameworks is that it doesn't ship a runtime like virtual DOM to the browser. Instead, it works as a compiler to turn your code into plain JavaScript. When you generate a new project, you'll have a rollup or Webpack config if you choose, which is used to bundle your code, and all of the other CLI tools attempt to abstract that part away from you. When building a Svelte project, you may need to learn a little bit about module bundlers, whereas the other frameworks try to hide that detail from you. Components are defined in .svelte files, and just like Vue, they have three parts: the script, the template, and the styles. To create reactive state on the component, just declare a variable with the let keyword. Then to modify the state, define a plain JavaScript function. What I like about this is that it feels very natural. It looks like regular JavaScript with minimal abstractions going on compared to something like React. Now to deal with lifecycle hooks, we can import the onMount function from Svelte and register a callback for when the component is first initialized. Now down in the template, we have a special syntax that makes it easy to loop over things like each to loop over each to-do in the array. Then to handle the form submission, we have onSubmit, and we can also add a bar with prevent default to avoid implementing that detail in the function. And lastly, we'll implement two-way data binding using the bind directive with value followed by the to-do text variable. In my opinion, this is the cleanest implementation that we've looked at. It has the fewest lines of code and is fairly easy to read if you're a JavaScript developer that has never used Svelte before. The drawback though is that the community is much smaller than something like React. So if you need to use a supporting library or if you're looking to get a job, you might run into some more roadblocks than if you used a more popular framework. And the same goes for all the other frameworks that we'll look at from here, starting with Lit. Lit is a Google-sponsored project that's focused on building web components. If you're not familiar, web components are a browser standard that allows you to create custom elements that can work across multiple frameworks. Sounds great, but the Web Components API is notoriously difficult to work with. The cool thing about Lit is that when you define a component, it's creating a standard custom element under the hood. Now, other frameworks can do that as well, but for most of them, it's just an afterthought, and the developer experience is usually not ideal if your goal is to build standard web components. Lit doesn't have a CLI of its own, but there is a starter project to get us going. I'm using the TypeScript version here, but that part is optional. Inside the lit app TS file, you'll notice that it's calling window custom elements, which is part of the Web Components API in the browser. That's just a unique point that you won't see in other frameworks by default. Components themselves are defined as a class that extends lit element. Reactive data can be defined as properties on the class using the property decorator. Then methods can be defined on the class to update the state. Lifecycle hooks are based on the ones defined in the actual Web Components API, like connected callback. By implementing the connected callback method, we can run code when the component is first initialized. Now, one thing that's really interesting about Lit is the way that it handles templates. It uses the existing template literals that we have in JavaScript, or in other words, a string that starts with backticks. This allows you to interpolate JavaScript into an HTML string using $ braces. The end result is something that feels kind of similar to JSX and React, but the HTML can also have directives like submit or .value to bind to the form submit event or the input value. And as far as I can tell, it doesn't support two-way data binding, so I had to set up an event listener here on the input change event to update the to-do text whenever that event fires. The bottom line with Lit is that you get a much nicer way to build standard web components without having to be an expert on the underlying APIs. And that brings me to an alternative framework that is also focused on web components called Stencil. This one comes from the team behind the Ionic framework, which itself is actually a component library for mobile development that's built with Stencil. They use web components for the purpose of making Ionic compatible with React, Angular, and Vue out of the box. Create a new app by running npm init stencil, and that will give you a TypeScript project to get started. Just like Lit, it will take each component and compile it down to a standard web component. A component itself is a class with the component decorator, which looks very similar to Angular. Then reactive data can be defined as properties with the state decorator. Custom methods can be defined to update the state. Then we have lifecycle hooks like component will load to run code when the component is first initialized. At this point, this component looks almost exactly like an Angular component, but for templating, it uses JSX like React. That gives you the best or worst of both worlds depending on who you ask. The template looks almost exactly like the React app, but it doesn't appear to support two-way data binding, which means I've also added an extra event listener for onInput to update the to-do text when the user types into the form. Stencil is another great option for building web components, but now we're going to move on to a framework that I get a ton of requests for, Solid.js. It's a tool for building UI components and feels very inspired by React, but the main difference is that it doesn't use the virtual DOM. Instead, it compiles your code down to native DOM nodes similar to Svelte. And because of this, it hits very high performance marks across every benchmark. You can think of it like a faster, more developer-friendly version of React, but the drawback is that it has a smaller community to draw from. When you generate a new project, it uses Vite as the build tool, which is cool. Then you have components defined in JSX files just like React. Components are defined as functions. Then to define reactive state on the component, we use something very similar to a React hook called a signal. It returns us with a reactive value and a function to update that value. We can then define a function to update the state. And if we want to use a lifecycle hook, instead of useEffect, we have the much more readable onMount hook that will run when the component is first initialized. Now for the UI itself, we use JSX. It looks pretty much identical to the React code, but I've noticed that Solid does things to make your life easier. For example, we can bind the form value to a variable using ref. And unlike React, we don't need to import the useRef hook to do that. Overall, Solid.js feels like a more well thought out and faster version of React. But now let's look at something totally different. Alpine.js. It's a tiny library at around 4 kilobytes that allows you to extend your existing HTML with reactive data and many of the features that you would find in the frameworks we've already looked at. Instead of primarily focusing on JavaScript, with Alpine, you generally focus on your HTML. If you've ever used Tailwind for CSS, you can think of Alpine as the equivalent in JavaScript. It has over 17,000 GitHub stars and is a popular replacement for jQuery. To get started, create an HTML file, then add the Alpine script to the head. Reactive data can be stored directly in a DOM node using the xData attribute. That data can then be used in a child element with something like x4 to loop over the array of to-dos. Then down in the form, we can use x on submit and also prevent default, and then bind it to a function in our JavaScript. The concepts here are very similar to the other frameworks that we've looked at, but in this case we're working with raw HTML as opposed to some custom templating language or JSX. Now if we do want to write some plain JavaScript, we can do that in a script tag. And Alpine actually has a mechanism called Alpine Store that allows us to store data and share it between multiple components in the UI. That's what we'll need to do for our to-dos so that we can load them from local storage. To handle that when the component is first initialized, we can call document add event listener to the custom Alpine init event, and then update the data from the store when that event fires. And that gives us a complete app with very minimal code. In my opinion, Alpine feels like an awesome option when you just want to add a little bit of JavaScript interactivity to an existing HTML page. But at the same time, I don't think Alpine could replace something like React, Vue, or Angular. So if you're building a very complicated single-page application, it might be best to stick with one of those. And that brings us to the final wildcard framework, Mithril. It's also very lightweight and tends to perform better than the big frameworks. It uses virtual DOM like React and Vue, but the overall developer experience is a lot different. To get started, create an index.html file, then add the Mithril script tag to it. You can actually create components from functions, classes, or as we're doing here, a plain JavaScript object. We can add data and methods to the component as properties on the object. There are also special properties like onInit, which is the lifecycle hook for when the component is first initialized. Then we have Vue to define the UI itself. To define a DOM node, we use the m function and pass the name of that node as the first argument, then options about the node as the second argument, like the class name, for example. Or you can pass children as the second argument, like we're doing here to map an array of list items. Then down on the form element, we're defining a handler for the onSubmit event. What you have here is something that is kind of similar to JSX, but the UI is truly defined in pure JavaScript. If you hate HTML and never want to touch it, you might like this system. But personally, I found it a bit awkward, and the Mithril app actually took me the longest amount of time to build. But like I said before, it really comes down to personal preference, and I could see why someone would really like this. And there you have 10 different ways to build the exact same JavaScript app. There are new frameworks popping up every couple days, so this video will likely be very outdated by the time you finish watching it. The bottom line is that all these frameworks can do the same basic thing. It's really just a matter of choosing the one that makes you and your teammates happy. If you want to see frameworks like Angular, React, and Vue in action, consider becoming a pro member at Fireship.io to get access to my full courses. Thanks for watching, and I will see you in the next one.